In-memory OLTP technology module is going on, and in this video we will talk about the in-memory OLTP and its basic components. We can define the in-memory OLTP as a specialized memory optimized relational DB component added into the SQL Server architecture. So this is the SQL Server architecture, and this is a component in-memory OLTP technology. So this component, when added into the SQL Server architecture, so it's improved the data load, and it improved the performance of transaction processing and data ingestions and transient data scenarios. So this component, we already told that this is introduced into the SQL Server 2014 12x, and then this SQL Server 2016 13x RTM version, and to the introduced in Enterprise and Developer Edition. But after that, this component is now available in all editions. So the basic components involved in this technology are memory optimized tables. Memory optimized tables are there are two types of memory optimized tables. So there's a durable and non-durable. These memory optimized tables are primary storage for these tables is the main memory. Memory, and they can read the data and write the data into the main memories. So data in memory optimized tables is only read from the disk when there is a recovery process needed. Maybe the server is crashed or server is restarted. So memory optimized tables syntax is this one. It's same like the normal table syntax we are creating before. Only we have to add this with the normal table creation statements, that with memory optimized is equal to 1. And durability is schema and data only. This is optional. If you will not mention this in the syntax, then by default it is schema and data. Schema and data mean, for the durable, the schema and data is preserved. Mean when the server is started, if the table is durable, then this table schema is also is saved, and it's the data which we entered into the durable table is also can be recovered. But in the non-durable table, which is the replacement for the temporary tables, non-durable table, only the schema is preserved, but the data is not preserved. So what will be happened when there is any server crash happened or server is restarted, data will be lost. There is no data available. Only that stable creation structure is available, which is preserved. So in this case, these cases, because these are residing into the RAM, so primary memory, so there is no disk input output is involved. So it reduces the input outputs. This is the performance gains. And to create the non-durable table, memory optimized tables, we have to write here the memory optimized is equal to 1, same like in the durable table. But this, the second thing we have to add here is the durability schema only. This we must have to add. If we will not add this one, then it will be act as a durable table. And how can we access these tables? We can access through two ways. We can access memory optimized table either by the native compiled stored procedures, or through the usual TSQL statement, transit SQL statement. So if we will access this by TSQL statements, so there is the performance gains. But if we will access through the native compiled stored procedures, the performance will be the boost, because when the client will execute the SQL statement to access the memory optimized tables through native compiled stored procedure, this request come to the protocol layer, and then this directly will execute this stored procedure to access the memory optimized table. So less instructions involved, CPU utilization will be less, performance will be boost. But for the, if that there is a TSQL, through TSQL we will access this memory optimized table, then it will go to the protocol layers, then it will be parsed and optimized, and this traditional interpreted TSQL query executor will execute, and then the query interoperation will also be involved, which will be responsible to access the data from the memory optimized table. So more instructions are involved, but still there is the performance as compared to the disk based tables. So this is the memory optimized tables which we are using less input output, but please keep in mind they are using more memory, but they will give the performance in compared to the disk based table in less input output instructions. So there are the now the second component is the memory optimized tables types. The memory auto create this is used to specify a predefined table definition. Suppose if you want to create a variable of memory optimized table type, so we have to define the table type. To define the table type, this is the syntax. It's same like the normal SQL table type syntax, but here we have to add the memory optimized is equal to on syntax to create this table type for the memory optimized. When we will create this type, so we can create the variable of this type. When we are creating the table type, we can mention that this index on this table type. It can be a hash index or non-cluster index. Hash index is a memory optimized table index which you used to use the bucket count, and this bucket count we also have to mention this that is like here is mentioned 1024. We can change a bucket is an 8 byte storage which is storing the row address pointer. And now we have created this table type. We can use by declaring the variable as salesman type because this is the table name, and we can insert the values using this variable into this table. This all uh, process is going on in the main memory, so less input output instructions will be used. Memory this performance gain, there is a performance gains. There is no involvement of the temporary db temp db, and so temp db will not be involved. So there is no locks, no contentions and locks will be involved. So there is the performance in this by using this memory optimized tables and memory optimized table types. This is the one of another component of memory OLTP technology, and which is also reducing the input output. And there is the third component for the memory optimized technology, which is a natively compiled TSQL module. Natively compiled stored procedure uses less number of instructions to execute the query and uses lesser CPU cycles. Of course, when there is a lesser instructions to execute, then of course there will be the lesser CPU cycles compared to the regular stored procedures. Like this is the architecture. If this is the if the normal stored procedure will be executed by the client, so it will go through all these steps. It will go to the protocol layer, CDM parser, optimizer, interpreter, TSQL, then the access method will be used, and this all will be used. But if it is a natively compiled stored procedure request by the client, then it will go by the protocol layers to the directly to this natively compiled stored procedure in memory optimized module. So it will execute directly this natively compiled stored procedure. Very less instructions, there is no involvement of these kind of instructions, very less instructions involved, so less CPU cycles will be used, its performance will be boosted. So these are the basic components of the memory in memory or OLTP technology, which are reducing the input output and which are reducing the CPU consumptions.